and welcome, Mindsetters. Welcome to this Learn Extra Live session for grade 12 maths. Hope you guys are ready. You've got your pens and pads out, and you guys are about to make some notes because I've got Natasha here who's going to be taking us through today's session. So, Natasha, what are we going to be doing today?
Well, grade 12s, we're going to look at 3D trigonometry. You know, for the last few weeks, we have been revising geometry and trig in the grade 12 session. So today we're going to look at 3D trig and just give you some tips and pointers.
All right. So, on that note, while Natasha makes her way to the board, Mindsetters, this is where I now say make sure you get your pens and pads out as I always do, and make sure you get on the page www.facebook.com/learn extra. I know you matrics are paying close attention because I know you've got exams right around the corner. So make sure you're making those notes. It's so important. That's why I keep stressing it. And yes, I have this awesome Casio calculator and this labeler to give away. So I am looking out for the best posts and for everyone who keeps on posting and regularly on the page. And I just want to send a quick shout out to Libby. Thank you for sponsoring. And this is the part where I hand over now to Natasha. Take it away.
Hi grade 12s and welcome to 3D trigonometry. As I said before, you guys have been revising 3D trigonometry, well not 3D specifically, but you've been looking at trig and geometry for the last few weeks, and we're just getting you ready for exams. So just doing a lot of exam revision and giving you an idea of what you should look out for. So today we're going to do a quick revision of 3D trigonometry before we look at some of the questions. All right, and some of the pointers, guys, you know, it's very difficult to talk through the theory of 3D trigonometry because really it's all about practice, practice, practice. You've got to have your diagrams, you've got to look at your diagrams, you've got to fill in information. So there's only really pointers we can give you, but you have to get those diagrams and you've got to just really work through them at home and, you know, send us through questions if you have any theory problems. But 3D trig is really not one of those sections that's just loaded with theory. It's just a lot of practice. Okay, so just some pointers is you need to take time to understand all of the given information that you get in your diagram. Always fill in as much information as possible on the diagram, and always work from the triangle with the most information. Usually all of your 3D trig can be isolated into separate triangles, and you would work within those triangles. When you're looking at 3D figures, remember you cannot work across dimensions. That's very, very important, okay? If something's in a horizontal plane, in a vertical plane, they're not on the same footing, they're not on the same level, so you can't put everything into one triangle. Okay, so just remember those kind of things. You cannot work across planes. You need to know all of your 2D trigonometry, all of your two-dimensional trigonometry, as you will need all of the rules that you have learned. Now guys, you'll remember that you started in grade 10 with 90-degree triangles. And in those 90-degree triangles, we taught you to use things to solve the triangles like sine of theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. But now as you got on into grade 11 and 12, you'll see that you don't need a 90-degree triangle to be able to solve the triangle. And that's when you use the sine, cos, and area rules, which is what we're going to quickly revise. All right, so first let's look at the sine rule. Okay, the sine rule can be used when you have more than one angle and a side. So guys, if you are taking notes, this would be a good note to make for yourself. If you have more than one angle, so I'm going to quickly draw a triangle A, B, C. All right, if you have more than one angle, so say we know what angle A is, and we know what angle B is, and they also tell us what side BC is. If you have at least two angles and a side, you can use the sine rule in that triangle. Also, if you have two sides and an angle that's not included, so another triangle, if I know two of the sides, so I know this side, I know that side, but the angle that I know is not between the two sides, so say it's somewhere there, then once again you can use the sine rule to help you solve and work out the angle in the triangle, and then work out the sides as you need them. So the sine rule, two times you would use it if there's more than one angle and a side, or if there are two sides and an angle. Just a reminder of what the sine rule says. All right, we've got sine A, and I know that you guys have revised this before, so I'm not going to go into great detail. Sine A over A is equal to sine B over B is equal to sine C over C. All right, so that's what the sine rule says. The cosine rule can be used when you have three sides. So if you are given all three sides in a triangle, you can use the cos rule to help you find the angles. Or if you are given two sides and an included angle. So if we've got triangle ABC, we know this side, we know that side, and we've got the included angle, then once again we can use the cos rule. All right, the cos rule, guys, remember what the cos rule says, and this is really just all revision because I know you guys have been working so hard, you know everything by now. So a squared is equal to b squared plus c squared minus 2bc cos of angle A. All right, so in a triangle ABC, you would find side A by using that formula. Guys, just a reminder, just in case you've forgotten, and I really hope that you haven't at this stage, but when you name your triangle, so if I've got triangle A, B, and C, the side opposite the angle is called little a, for example. So if I'm looking at angle A, the side BC would be called little a. If we look at angle B, the side opposite angle B, which is side AC, would be called little b. All right? And then the side opposite angle C, which is side AB, would be called little c. All right, so remember that's how we name our triangles. So if we relate our diagram using the cos rule, we've got a squared is equal to the sum of the other two sides squared minus 2 times the product of those two sides times cos of the included angle. All right, so obviously for the cos rule to work, you will need to have those two sides and your included angle. And then finally, we use the area rule of a triangle when we need to obviously find the area of a triangle. In order to use the area rule, you need to have at least two sides and an included angle. So you have to have at least two sides and an included angle. So if necessary, you can work out the area rule, the formula for the area rule. So if, again, working off a triangle ABC, the area of triangle ABC is equal to a half of the product of two sides that you know, and then sine of the included angle. All right, so it just depends on which sides you've been given, guys. So in this case, if I've got side A and B, I would need to have angle C in order to use the area rule, and you can go around the triangle in that way. You need two sides and an included angle to use the area rule. So that's just a little bit of theory, and that's really the only theory we can give you, but just a reminder that when you get your 2D or 3D trigonometry problems, you mark down as much information as you possibly can gauge from what they've given you. All right, and I think, Ty, should we take a break now, or should we go into our first question?
I'm thinking we should jump into our first question.
All right. Okay, guys, so let's get ready for this. It is quite a long one. So we're not going to have a break in a while, so stay glued to your seats. All right? So we're going to, as I said, the best way to do 3D and 2D trigonometry is to work through an example. All right, and hopefully you guys can see this diagram, and it is big enough on your screen. We are told that in the figure, A, B, and C are 3 points in the horizontal plane. So they're in a separate plane compared to, for example, ADB. All right, they tell you that angle ABC is 120 degrees. D is a point directly above A, and AD is equal to BC is equal to Y. So all the information they've given you is really on the diagram. And they tell you the angle of elevation of D from B is theta. Okay, so they tell you that that angle is theta. Now, we can write down a little bits of information, but they're not going to really help us with the question, as you'll see in a little while. So I'm not going to make any other little marks there until we have a look at what the question wants. Okay, so the question is asking us to find AC, and they've given us a formula. So this is really, guys, this is a typical test kind of situation. They'll say to you, show that AC is equal to, and they'll give you some expression that usually looks very strange, and you think, oh my word, how on earth am I going to get tans and thetas? And theta is in a completely different triangle to where AC is. But don't let all of that get you confused, okay? Remember, in 3D trigonometry, you work with the triangles with the most information, and usually there's always a joining side between the two triangles that will help you to take you from one triangle into the next. So what I'm saying is, if we look at the diagram we want AC, all right? We see that theta, though, is in triangle ADB. There it is. But now there is a side that joins triangle ADB to triangle ABC. And hopefully all of you can see that that side is side AB. Okay, so AB is the side that joins the two triangles together. It's also the side that will help me to take that angle theta from triangle ADB and use it in triangle ABC. Okay, so that side is a very important side because it's the one that joins everything together. So if I am trying to find AC, the first thing I'm going to need to do is to find AB because that's the joining side. All right. So how do we find AB? All right, now remember, we're working in two different planes, so we've got to isolate the two triangles. So, or the one that we're working with, there's actually three triangles here. I'm going to look in triangle ABD. I want side AB, okay? Because we have a 90 degrees, hopefully you guys can see that in blue there, we have a 90 degree at angle A. So therefore, I don't need the sine, cos, or any of those rules yet. I can just work with my 90 degrees. All right, I want side AB. I know that angle B is equal to theta, so therefore, AB is the side that's adjacent to theta. And the side that's given is that one, AD, and that's opposite theta. So if I set this out, I can say, since I'm looking for remember AB, tan of theta. All right, so in that triangle ABD, tan of theta is opposite, which is AD, over adjacent, and your adjacent is AB. I'm looking for AB, so if I rearrange this formula, I'm going to get AB is equal to AD over tan theta, and I just get that by cross multiplying and then dividing. All right, so AB is going to be equal to AD over tan theta. We know that AD is equal to Y. So therefore, if I replace AD with Y, I get that AB is Y over tan theta. And so if you're looking at the question, they want you to find AC, and you started off a little bit confused. Hopefully you're feeling a little bit better because now we've got this Y and the tan theta. All right, so we've got Y, and Y over tan theta is side AB. All right, and I'm just going to erase all of these marks that I've made on this drawing so that you can see what's going on here. There we go, that's better. Okay, so we've got AB. We want to find AC. What do we have in triangle ABC? Remember, now we're in a completely different plane. We're in the horizontal plane. So if I look at triangle ABC, I have just worked out what AB is. I know that BC is Y. They tell me that. So if I'm looking for AC, all right, hopefully you guys can see we've got two sides and an included angle. So the easiest way to find AC is going to be by using the cos rule. All right, so let's set this out, and I'm just going to go away from the diagram for a little bit just so that we can get some space here. So remember, we're looking for AC and we're using the cos rule. So AC squared is equal to, it's going to be AB squared plus BC squared Okay, remember it's the sum of the two sides minus, it's the sum of the two sides squared minus 2 times the product of those sides. If you wanted to, guys, you could have labeled these with little a's and little b's and little c's, but because we've got so many triangles together here, I'm just leaving them as the names of their sides. So we've got it's minus 2 times AB, BC, cos of the included angle, and here our included angle was 120 degrees. So I'm just going to put that in, and hopefully it'll all work out very nicely. All right. So AB, remember we've just worked out AB. We've got that AB is y over tan theta. So I'm going to put that in. And that's all squared. Plus BC, and if we go back to the diagram, you can see that they gave you that BC was y. So it's going to be plus y squared minus 2 times AB, which was y over tan theta, and then BC was y. Cos of 120 we can rewrite, and this is why we always say grade 12 is really testing 3 years worth of work, because cos of 120 we've got to use reduction formula, which we learned in grade 11. Cos of 120 we can rewrite as 180 minus 60. Okay, all right, so let's simplify this a little bit. All right, so if I square y over tan theta, I'm going to get y squared over tan squared theta plus y squared, we're just going to leave alone for now, minus 2. And if I simplify those brackets, I'm going to get y times y, which is y squared, all over tan theta. Now guys, remember, using a reduction formula, cos of 180 minus 60, that's in the second quadrant where cos is negative. So this is going to become negative cos of 60 degrees. Okay, and hopefully you all realize that 60 is a special angle. All right, so minus times minus is going to give me a plus. Cos of 60 is actually a half. So if I times a half by this 2y squared over tan theta, that's going to just cancel out. So this second lot of the expression is going to give me positive y squared all over tan theta. So that's the second half of the expression. All right, and then the first part I've just got y squared all over tan squared plus y squared, and then we've got all the rest. Now, if you look at this, and if you look at what they asked you to prove, it's the square root, y times the square root of 1 over tan squared theta plus 1 over tan theta plus 1, hopefully you can see the link already, because if I just take the square root now and rearrange this, it's going to look exactly like what they've asked us to solve. Okay, so let's quickly do that. All right, so the first thing I'm going to do is take y squared out as a common factor. And I'm just going to rearrange this. So I'm going to get 1, okay, let's try that again. So I've taken y squared out as a common factor. I'm going to be left with 1 over tan squared theta plus, and I'm just going to rearrange the terms. So I'm going to get plus 1 over tan theta. And I've taken y squared out, so it's just going to leave me with 1. All right? We're looking for AC, not AC squared. So if I square root both sides, the square root of y squared is just y. And it's going to get, and then I'm going to be left with the square root of 1 over tan squared theta plus 1 over tan theta plus 1, which is exactly what they asked us to prove. All right, so we have the length of AC in terms of y and in terms of theta. At this point, because it is quite a long question to go through, I'm just going to cross over to Ty, see if any of you have any issues or any questions you want to ask on the first half of the question, Ty?
So far, there is quite a couple. So right now, I'm in the process of sifting them out for you.
Okay.
So that's what we're gonna do. But I think it will also be a good idea to take a quick ad break so their minds don't just melt out of
Yeah,
their ears.
and then we'll carry on with the second half of the question.
Okay, no problem. So on that note, mindsetters, do not disappear, do not go anywhere. Make sure that, okay, if you really have to go to the bathroom if you must. But on that note, make sure you come back because we're going to see you after this break.